The Progress in Addition and Subtraction by Valeria Tapia. So counting begins in kindergarten, and they begin to count objects like these blue blocks here, and they always count forward, like 1, 2, 3, 4, 5, or count backwards from 5 to 5, 4, 3, 2, 1 to 0. Always make sure to include 0 in this, as it's very important. Let's see. And as students begin to work on counting, they also begin to count sets, as here a student has one set of 2 in one hand and one set of 3 in the other. And they're not able to put these two sets together yet, because there'll always be a set of 2 and a set of 3. But then as students move on from counting sets, they begin to move on to joining sets. And so they're able to combine the 2 and the 3, and the 2 and the 3 become 2 and more is 5, or 2 plus 3 is 5. And as students begin to work on this idea of joining sets, we introduce 5 frames. So we'll have 3 and 2, and we take away a 1 from the 2, and it becomes 4. And so it goes 3 plus 2 becomes 4 plus 1. And the answer remains the same, it's 5. And this understanding will build up with students when they begin to use 10 frames later on, which is in, I think, 1st grade. And in terms of subtracting, students can have 3 minus 2, and they can use a separate model or a compare model. And for this, context should always be the driver what strategy students use, as, different context means different strategies. And so children are working on addition and subtraction simultaneously, and they're working on the understanding of counting and collecting and grouping things in 10. So here, 14 could be seen as 10 and 4 more, or 10 plus 4. It's here that this whole idea of unitizing is introduced. It's massive, and we need to make sure students don't leave kindergarten into 1st grade without understanding this conceptually. So as students dive into the 1st grade, they begin to explore sums greater than 10. So what that might look like is 9 plus 5, and they can model with the 10 frame as it's done here. And they begin to work on the idea of unitizing, or they begin to see that it's the most efficient way to solve a problem like this, and that they can fill up a 10 frame and it will give them the answer. So here they take away 1 from the 5, so it becomes a 4, and the 9 becomes a 10. So 9 plus 5 becomes 10 plus 4. And so this leads students to begin to think flexibly about numbers and understanding, and this applies to double digits as well. And the thing is that as long as students are using concrete models, then they're also drawing representations. So here we want to unionize to make 10. So we take this group of 8 right here, and this group of 5, these 3 singles, and this other 2 singles, and we unitize it to make 10. And then so the 32 plus 8 equals 40. Let's see. And then so what this looks like for subtraction in 1st grade, well, students are usually only subtracting a multiple of 10. So here we have 47 minus 20. And they see that if we remove 2 10s, as done here by slashing them, they are left with 1 set of 10, 1 set of 5, and 2 singles, which equals 17. And so what happens in 2nd grade is, how does this build on what they've learned in 1st grade? Well, they might use two-digit numbers, and here's where we begin to introduce base 10 blocks because of the whole idea of unitizing that students are still developing in kindergarten. And first, again, just like before, we'll draw a representation of our model, as done here. And we'll create another bundle of tens, and here's how students can begin to move from concrete to representation to the abstract. It might not be, sorry, oh no, oh, oopsies, sorry. And students might see that it's not as efficient to write out everything, and so they can become more efficient by beginning to understand partial sums and find the shortcut as shown right here. So 28 becomes 20 plus 8, 33 becomes 30 plus 3, and then we just subtract down, or add down, 8 plus 3, 11, 20 plus 30, 50, so we can easily see that's 61. Or we can also do 50 plus 10 plus 1 equals 61, which is a shortcut. And for partial sums, it's 28 plus 33. We just add it down as we did in the other side. So 8 plus 3, 11, 2 plus 3, 50, 61. Don't forget about place values, as they're very important. But does it work for subtraction? Does doing that kind of thing work? Well, I want to try to use models that continue to work the same and consistently through math so that they don't expire. So here we have 33 minus 24, and we're going to separate 24 from 33. So here we have it, 24 right here, taken away from 33, and it becomes 9 singles. And this is a really big understanding for students where they make that fair trade and that idea of unitizing. And let's see. Okay, let's see. And as you can see here, we do partial product as well. And on to the next page, because I ran out of space. And what we were doing before also applies to big numbers. So here we have value maths, which all equal, 200 and all. Anyways, students are still acting out that fair trade and they're making sense that we're grouping the numbers. And so what it would look like for this number, we'll regroup we're going to take away 135 from 223. So here we have it, them all rolled out. And then it becomes 88 right here, as you can see, the 10 blocks and the 8 singles. And this is all about students seeing the math conceptually, and they're not undermining the place value. And as students dive into the their third and fourth grade, they have 2 years to begin to formalize this understanding of subtraction and addition with regrouping and unitizing. So the big thing is that it's built through conceptual understanding. The standard algorithm isn't an expectation until the end of 4th grade, right before students dive into decimals. Before students dive into decimals with 5th grade, and you know that in 3rd and 4th grade, if students need to use expanded form to make sense of what they're doing, let them do it, as done here by 5,000 plus 700 plus 40 plus 3, 2,000 plus 500 plus 60 plus 0. That is an expanded form, so they understand what they're doing. It's all about conceptual understanding and allowing students to visualize the math, since all of this presentation has been just visualizing. And that is all. Thank you.